Good morning. This video is going to document how to take a ceramic heater for use in an electric vehicle, run it off of a 12-volt battery through an inverter, and provide a reasonable amount of heat. In this system, I have the ceramic heater. I've taken apart a comfort zone unit. It's about 18 bucks from Walmart. Over here, this is a inverter I bought online, 31 bucks. Is a 1500 watt Doxin unit. And then I'm using just a basic red top opna for power. You will need to have a plug. I accidentally threw away the plug for the comfort zone heater when I disassembled it, so I just had to grab another one and cobble it together. We'll be using the original instrumentation to control the heater. When you make your electric vehicle, you can use that or change it up however you see fit. Alright. The battery we're using is an Optima red top. We purchased it back in 2010 as part of a set of batteries for an electrothon vehicle. We've been using it ever since. It does sag significantly after use, but we just charged it up and it was showing 13 point something volts. I do have, as part of the circuit system, I do have a digital voltmeter, so when we do hook it up to the battery, you'll see how many volts it's carrying. One of the neat features about this ceramic heater is that it's self-regulating and self-limiting, so you can't put too much current through it because it'll basically, the resistance increases as you put current through it. I did try originally to hook it up just to the 12-volt battery, and it only raised the temperature by about 2 to 3 degrees after several minutes of use. I looked online, and there were several forums out there that said use an inverter, so I found a 1500 watt unit. Got this on I think it was eBay or maybe even Amazon.com, but it was $31, so that works. If you're looking for a comfort zone as a heater, you make sure you get a ceramic heater. Don't get a quartz unit or anything else. One of the things I like about the Doxin unit is it comes with some pretty stout supply or source cables that you can clip right to the battery. It also has a universal plug on it, so you can use it for any power source. The on and off switch, I did notice, I hooked it up earlier, and I did notice that the power will cycle on. When you turn it on, it'll power on with the green light, and when it gets too much, it automatically cycles off with a red light, and then it cycles back on again. So it will actually, you don't have to do any reset or fuse correction. I'm going to plug in the battery now. So negative goes to negative. Currently no voltage. Positive is positive. Little sparks as the contact is made, and we're sitting at 12.9 volts. I'll give it a minute and see what it does as far as stabilizing. While the battery is stabilizing its voltage and getting a good current, I'm going to show you what I've got set up here. I've got the original control panel from the heater that normally would be on the top of it, and I've got it just wired in so it's right next to it. The fan will not be working because we took the fan out of it completely. We'll be using the vehicle fan for that. I've got the thermostat a little bit more than halfway up as a heat setting. What I'm going to do is I'm going to plug it in to the wall and get a baseline heat level of both the low and the high coming off of the coils. I've got my non-contact thermometer, so I'll be able to get the temperature from that. So plug it in, it's in the wall, and it's resting temperature right now it's sitting about 78 degrees across the whole surface of the ceramic heater. We go and turn it on to low, and let's see what happens. Alright, it's already up to 150 in the center, 250 in the outside area, so it's cooler in the middle, hotter on the outside. Well, okay, correction. So it gets warmer to the right you go. So you see it's up 300 degrees on that side, 200 in the middle, 110, and ambient temperature. So it looks like it's heating up on that side hottest at the low temperature settings. Okay. Now we'll set up the high temperature setting. Come on now. I'll do it one-handed here. Alright, let's see what the high temperature does. Alright, looking at 370, 380. The middle is going to, it's about 195. Almost, okay, about 300 in the middle, 400 on the end, and about 160, 170, ranging between those ranges. Should I go this way with it? So we're getting about 300 degrees, 400 degrees off the coils on the high setting. So around 400 degrees. Now, I just unplugged it, so after several seconds, the temperature actually still stays around 300 to 400 degrees. So the ceramic is maintaining a good temperature, a good heat. But what I'm curious about is how well it holds on to it while it is, it's got air blowing through it. So I'm going to pick up the case of this carefully, and I'm going to hold this in the airstream. Actually, I'm going to place it in the airstream, and we're going to see what air blowing through it does to the temperature. So right now it's sitting at 300, and it's dropping. That's about what we expect, because as air blows through it, it'll drop. But the ceramic is doing a great job putting off a lot of heat. One thing I wanted to see is how the heat did at dissipating, or however the fan did, air movement, did with dissipating the heat on there. So we're going to go ahead and see what it looks like. And with it running, this is at full heat. So normally it was sitting around 400 degrees. And you see it's somewhere hovering around 330 on average. So it's around 340, maximum 340. So the fan movement, air movement, is definitely helping to dissipate the heat. It's not getting all the way up to 400 degrees now. Maximum around 344. So that's not too bad. The battery seems to be stable at 12.9 volts, and we're going to hook up the ceramic heater to the inverter in a minute. But one note is that I will definitely be running air through the ceramic heater whenever it's running. So I don't think it'll ever get quite up to 400 degrees like it was showing before, even if the inverter gets it that hot. I've got the heater plugged into the inverter, battery's still holding, sagged down to about 12.8, just sitting there, resting state, and so that's only about 0.1 volt change. So we'll see how it does. I'm going to turn on the inverter, and right now the heat is set for on fan, which basically means no heat. So I'm going to turn it on. A slight whining sound from the inverter, basically could be the fan, and it just dropped down to 0.1 volt. Let's see what that does. And we'll keep an eye on the voltage to see what happens as it goes along. So we got the voltage on. I'm going to go ahead and turn it on to just the low heat setting. Alright, we're on low heat right now, and it drops immediately down to about 11 volts, down to 10.9, and it holds there. And you can see that the power line is on, and it goes back up to about 11.5, and it'll slowly creep up to 12 volts. Now as we're doing that, we can see the temperature of this thing. It's already up to 300 degrees on the outside, about 200 in the middle, about 99, so almost ambient temperature on the end, because it was about 98 degrees when it was done. And the voltage is going back up slowly to about 12 volts, so it'll slowly go back up. And that's at low heat with almost 350, 360 degrees on the outside coil. So it's only powering the outside one and not the poster one, or I should say the far side one and not the poster one. And as we watch, the voltage is going to slowly creep up. So other than an immediate sag in voltage, it is maintaining a pretty constant voltage. And it's pretty steady around 370, 380, so it's getting close to the same levels as it was when it was plugged in. Okay, now we're going to kick it into high gear and you'll see something happen with the inverter. We'll check the heat as well. So we're going to go all the way high. Alright, we're at high and you can see the voltage immediately drops down and kicks back up again, because what's happening is you can see the inverter is cycling on and off. But it's cycling on and off, and the heat is definitely climbing across the whole board slowly. You can see even on the near side it's slowly getting up warmer. So it's definitely having an effect on the heat, but it's just not as efficient. So a little bit more heat is causing the inverter to cycle on and off more often. But it's definitely putting out a bit more heat. We're about 50 degrees warmer on the near side than we were before. But we're only about 30 degrees warmer, actually not even that much, on the far side. So it may not be worth it to have it cycling on and off. Now what's interesting, after cycling on and off over and over again, it's stabilized. Now it could be because the thermostat kicked on, but now it's stabilized. It's not cycling on and off anymore. Let's see if it's the thermostat. Let me turn the thermostat up a little more. Nope, not the thermostat. So it appears that voltage is stabilized. Temperature is comparable to the wall outlet temperature. So we've been able to replicate the wall outlet conditions, and even though it was cycling on and off, it is now stabilized, and that is at full power, maximum heat, high heat. So, holding steady 11.9, we'll see if it gets up to 12. Well, you may be wondering, what happened to the plastic case? Well, I decided to run this thing for 10 minutes, and after 10 minutes, voltage hasn't sagged much at all. It's still maintaining 11.9. But the plastic case has suffered a little bit because, well, it started melting into it. I thought this was a fairly high temperature plastic. It's only good for about 300 degrees, maybe 350. So since this thing was getting up to about 400 degrees, and actually it's still maintaining about 400 degrees across the circuit, yeah, it didn't handle it very well. So the good news is now I know to make a housing that's much more resilient to heat. But actually that's the only bad news, is I have to make a different housing, but it'll still fit in the same location, and it's only sagged at, well, it's 11.9, so it hasn't changed anything. So I'm going to go ahead and turn off the heat, and it goes up to 12.2. That's with the inverter on. 12.3. I'm going to turn the inverter off now. All in all, not a bad test. Yep, there's 12.4. So, yes, this ceramic heater will work for an electric vehicle as long as you use an inverter. This is a 1500 watt Doxin unit. Pretty sturdy little thing, I gotta say. So far, I'm pretty happy with it. So we'll see how it looks, how it works when it's in the vehicle.